Welcome to this video, Unit 4.4, Water Pollution. We're going to have a think in this video about management of water pollution, specifically in the context of eutrophication. So as we know with ESS, there are concepts that go all the way through. The concepts that we'll be looking at here will be the concept of stewardship, stakeholder engagement as well. So we can talk about all of these things. We can talk about publicity strategies. But if you don't have proper stakeholder engagement, they're not going to be particularly effective. Also, we're going to remind ourselves about the concept of external costs and externalities. But for the first question that I would ask you is that if you look in the textbook, lots of countries introduce guidelines and publicity campaigns. For example, the one in the textbook was Australia, where you give people guidance on, for example, encouraging them to use phosphates-free detergents. I want you to have a think about that. Will enough stakeholders make the correct decisions just out of an ethical or moral basis, just as a result of guidance? And what we tend to find is probably that is not the case. So what I would suggest here is that stakeholder engagement is really important, but also that you do need to have a legislation, a law structure and a taxing structure that forces people to reduce, for example, their phosphate footprint. In the English language, we often use the concept of a carrot and a stick. You can dangle that carrot in front of a donkey, and the donkey will walk towards the carrot. But it's much more effective if you hit the donkey on the behind with a big stick. A carrot and stick approach. So I'd like you to have a think about that. At the end of the day, consumers, stakeholders don't know the correct decisions that they need to make. They may be empowered to make those decisions, they have those opportunities available to them, but they won't necessarily do that. Then we also need to think about some geographically specific strategies that we could use to control eutrophication of water and control water pollution. And here in this infographic, which you can take a look at, we've got mid-latitude strategies. Okay, so there you are talking about doing special things there. So in particular, avoid using nitrogen fertilizers excuse me, during the wet season because they are more likely to be washed off. Okay, you give preference to autumn sown crops. So you keep that root structure all year round. In the winter, you will also have that root structure, and that will help with nitrogen retention. Sow autumn crops as early as possible. The worst thing that you can have is bare soil on your farm. So sow those crops as quickly as possible. Simple things like do not apply nitrogen fertilizer in a field that is near a stream or lake. Now, a common practice is to have a buffer zone around a river or lake or any watercourse. Sometimes that's legally enforced, so you'd have a 50-metre buffer zone around a lake. That can be, in many countries, that's legally enforced. Satellite technology, satellite surveillance is really useful for monitoring that remotely. Again, quite obvious thing here is do not apply nitrogen fertilizer just before there's heavy rain, and use less nitrogen if the previous year was dry. Because if the previous year was dry, there will still be more nitrogen left in your soil because it hasn't been washed out. So strategies like that. Now the problem with that is that we get there the concept there of stakeholder engagement coming through. And the problem there is just because you engage with your stakeholders doesn't necessarily mean that they follow through on these things. So if you have a look at this infographic, if you want to pause the video and have a look at it, you will see on this infographic there's also a legal framework that backs this up. That carrot and that stick approach is very important. It's much more beneficial if you stop the pollution as far as you possibly can at source. So if you know the water is going to be toxic, you divert that water into containment ponds. Here is a toxic water containment pond in Montana. For some reason, I'm not quite sure why, this is a bit of a tourist attraction. I think it's because it's such a peculiar and beautiful colour that people actually do come to watch, do come to look at it. But actually, the water contained in there is very, very toxic. It does mean that the toxic water is still there. When it evaporates, it leaves nasty toxic goo and sludge behind. So again, is this really a very good, very good solution? Another way is that you could divert that water and treat that water naturally with reed beds. So here, that you take the nutrient-rich water, you can see that it's pumped in underground to a reed bed. They supercharge this by aerating the reed bed, so they actually pump water into the soil, and that increases the amount of biological activity there. It gets the plants to grow faster. Those plants then absorb the nutrients. Nice thing here is that those plants themselves can sometimes be used as a biofuel. They can be used as a compost, and they can be used for a sustainable building material as well. So that's quite a nice little system. So like we said there, in part of managing eutrophication is realising that you have enough oxygen to meet that biochemical oxygen demand. So one very, very common way, anybody that's been to Bangkok will see this, is actually pumping air into the water or agitating the air in the water with those great big wheels. So there, it does make a surprising difference. So when you get air into the water, you meet the biochemical oxygen demand of the water, and things start improving very, very quickly. Anybody that's lived in Bangkok and actually seen these things installed into highly polluted canals, it's really quite incredible how quickly these can make a difference. So another thing there is we got water pollution management. That's the removal of biological material, the removal of weeds. That's going to help. Also, there's the removal of primary consumers such as fish. It gives those little critters such as Daphnia a chance to reproduce. They're much more biologically active, and they can help to reduce the nitrate and phosphate content of the water. Restoring wetlands. Wetlands are tremendous carbon sinks. They also help to absorb those nutrients as well. So if you restore the wetlands, here you can see somebody restoring a wetland by planting reeds. Do remember, as well as composting sinks, carbon sinks, there's composting, and it can provide a source of fuel. Another thing that you can do, an awful lot of phosphates and come from sewage. So there is a process of stripping those nitrates out by adding zinc phosphate. And by adding zinc phosphate to sewage, you can reduce the content by about 90%. So in this video, we've seen that there are a variety of strategies that we can use, and those strategies lie on various parts of the environmental values spectrum. There's some quite technocentric responses, and there's some ecocentric responses as well. In this video, we've also considered the importance of stakeholder engagement. And we've also started to considered further how this is a system with inputs, outputs, stores and processes. Okay guys, hope you found this video useful. If you like my videos, please do give it a thumbs up. Consider subscribing to my channel, and maybe if you have time, leave a comment.